Okay, here are our select practice problems for this lesson. So we are going to go over problems 1 and problems 5. Okay, so let's start with problem 1. So problem 1, we are going to test it basically to see if if these are inverses of each other. That is what we are doing with all of these on this particular practice. So we've got two functions, f of x and g of x. All right, so what the test is, we're going to start with finding f of g of x, that composition, and see if we get the identity function, which is basically y equals x is our identity function. All right, so let's try it. All right, so g of x is 2x minus 3. All right, and then when we find f of g of x, which is another way of writing it, you're going to take f of x and write it with leaving a space where x is for us to put in our other function. Right, so we have 2 times blank, whatever x is, plus 3. So we're going to put 2x minus 3 here. Okay, so we go this times this, and then we're going to add 3 to it. So we're going to get 4x minus 6 plus 3, and then hopefully you start to see right away doing this that you get something that is clearly not the identity function. You get y is equal to 4x minus 3, not the identity function. So you can firmly say no at this point. Let's do it the other way to see if maybe the order in which you start would make a difference. All right, so if we did this first, right, if we said we're going to do f of x first, okay, and do that. So if we did f of x is equal to 2x plus 3, and then if you plug that into g, right, so you go g of f of x is equal to 2 times 2x plus 3 minus 3, right? Well, you're going to get something that's actually pretty similar, right? So you're going to get 4x plus 3, which is a clear no as well, right? So they are not inverses of each other, and that's pretty obvious. All right, so not inverses of each other. Okay, and so now for number 5, we got 2x squared and square root of 2x. All right, and I picked this one because a lot of people kind of get freaked out by radicals. So, you know, we're going to try and work on that and eventually do some stuff with radicals to help allay that. So the first thing we're going to do is we're going to find g of x, all right, because we do f of g of x first. So you work from left to right on these. And so g of x is equal to the square root of 2x. All right, and so now we're going to go 2 times x squared, which is, let me write this out here, getting ahead of myself, 2 times the square root of 2x squared. So this right here is putting this in, and this was the space left by x, right? And so you get 2 times, well, square root of 2 squared and square root of x squared, just going to give you 2 times 2x, right? Whenever you have the square root of something and you square it, you get whatever is under that radical, right? And so you get 4x. And so this is another case where you can basically stop and say, no, they're not inverses of each other. But like I've been doing, I'm going to just prove the point, and we're going to try it the other way and see if maybe for some reason we get a different result. So you get f of x is equal to 2x squared, because you do this one first. And then for my g of f of x, I'm going to leave a space 2 times, and then we're going to put this where x is, right? So we get 2x squared, right? And then what you get is you get square root of 4x squared, right? You just multiply these together. Apologize about all the racket. And then when you take the square root of this, you get 2x. So you get things that are similar to each other, right? But they're not the identity function, right? They're not this y equals x. So that is what we are looking for, right? Is that y equals x. That is our identity function. And identity function. So we did not find that in either of our examples. So in both of those cases, you can confidently say they are not inverses of each other. and you are done. So thanks for your attention to this, and yeah, thanks for watching, and good luck with the rest of these.